We've been talking in the last couple of videos about the limit as x approaches infinity of rational functions. And we've determined that we really need to look at the highest exponents in the numerator and the denominator. If the highest exponent of the numerator is larger than the largest exponent in the denominator, then the limit is always approaching infinity. If the denominator has the biggest higher exponent, then the limit is going to be 0. And if both of them have the same highest exponent, then the limit is going to be the ratio between the coefficients of those greatest terms. And so in our last video here, what we're going to do is we are going to look at the limit as x approaches negative infinity of some of these same problems that we've been doing, because things are going to work out a little bit differently. Negative infinity is sometimes going to change our answer around a little bit. All right, so what about the limit as x approaches negative infinity of 2x plus 1? So as x gets to be more and more, greater and greater, but still being negative, multiplying 2 times that is going to give us a very large negative number. And adding 1 to that very large negative number isn't going to keep it from being a very large negative number. And so a very, very large negative number, we're going to call that limit negative infinity. Okay, so that probably seems pretty obvious. Let's take a look at the limit as x approaches negative infinity of x squared and see how that changes. Well, the limit as x approaches negative infinity. So think of x being a very large negative number and plug it into this and see what you get. Well, we're multiplying a very large negative number by a very large negative number. And so the magnitude of that number is going to be large, but the number isn't going to be negative because the two negative signs are going to cancel each other out. A very large negative number times a very large negative number is going to be a positive very large number. So the limit of this is equal to positive infinity. Okay? But by contrast, if we took the limit as x approaches negative infinity of x cubed, now, one way I kind of explain this to talking about a student is you can kind of think of this as negative infinity times negative infinity times negative infinity. So the magnitude of this is going to be infinity. What's the sign going to be? Well, 2 of these negatives are going to cancel each other out, so they'll become positive, but the third negative is still going to carry the day. So when you're raising x to a negative or to an odd exponent, it's going to be negative infinity. But when you're raising it to an even exponent, all of those large negative numbers, the negatives are going to cancel each other out, and you're going to be left with positive infinity. Okay, so this makes IXL problems a little bit tricky, and I'll be honest with you, sometimes I get them wrong because you've got a lot of opportunities to kind of goof things up a little bit. All right, so let's take a look at some examples of more complicated rational functions. All right, so the limit as x approaches negative infinity of, let's say, 3x squared minus x plus 2 over x plus 7. Okay, and what I might do is I might do this same trick I did right here. All right, so the first thing I do is I realize that the numerator is growing faster than the denominator. So the answer is infinity, but it might be positive infinity, it might be negative infinity. I got to do a little extra checking out to figure out which is the case. So let's think about the sign. So what about the numerator? What is the sign of this going to be? Well, this is 3x squared. That's going to approach infinity. Minus x. But again, even thinking about the sign, the extra terms are going to not be important. So I don't need to worry about this x being an odd power, being an even power. I only need to think about the leading term, because the other terms are just going to vanish as x gets really, really big, even as it's approaching negative infinity. So 3x squared is going to approach positive infinity. And what's x plus 7 going to approach? Well, x plus 7 is going to approach negative infinity, because x to the first power, this is an odd power. Okay, so I kind of want to think about that as positive infinity over negative infinity. The only reason I'm thinking about this is that I want to be sure that I'm doing the right sign here. All right, so that's positive infinity, that's positive over a negative, so that is going to be negative infinity. That's a really important thing to keep in mind, even though the numerator is growing much faster than the denominator. The fact that the denominator is negative means that it's going to flip the sign of this positive numerator. Okay, so when you're thinking about one side dominating another, you got to think about the sign as being a separate thing. All right, let's take a look at a different case. Let's say the limit as x approaches negative infinity of, we'll say 3x squared plus x plus 2 again, over x to the third plus 7. All right, so what does that equal? Well, what we can see here is that the denominator is growing much faster than the numerator. So that tells us that our limit is approaching 0. Do we need to think about the sign in this case? When it was approaching infinity, we weren't sure if the answer was going to be positive infinity or negative infinity. When the limit is approaching 0, do we need to worry if the answer is positive 0 or negative 0? Well, no, we don't really, because positive 0 and negative 0, if there were such a thing as negative 0, they would be at the same spot on the number line, right there between all the positive numbers and negative numbers. So actually, when x is approaching negative infinity and it is approaching 0, we don't even need to make a special case when x is approaching negative infinity. Our answer is going to be 0 either way. So that was a nice gift for us. And what about the limit as x approaches negative infinity? We'll stick with 3x squared plus x plus 2 over 4x squared. Now let's say 3x cubed. Sorry, plus x plus 2 over 4x cubed. Let's give ourselves a little bit of extra space there. So what we would figure out if x were approaching infinity, this would be approaching, since these are both the same power, we would say that it's approaching 3 over 4. Is it the same thing when x is approaching negative infinity? Well, let's break this down the same way we did in the problems before. So this is the limit as x approaches negative infinity of, when we get rid of those irrelevant terms, we've got 3x to the cubed over 4x cubed. And once again, all of our x powers are going to cancel out. So in this case, yeah, it doesn't matter at all that x is approaching negative infinity when we've got this case. It's approaching the same 3 over 4. All right, so this gives you a little bit of an idea of how things change when our limit is approaching negative infinity over positive infinity. If both of the exponents are the same, and so we're looking at the ratio of the leading terms, it's the same answer whether you're approaching positive infinity or negative infinity. If the denominator is growing faster, we've got the same answer that we did in the other case when x was approaching infinity. Our limit is going to be approaching 0 whether we're approaching positive infinity or negative infinity for this problem. But when the numerator is growing faster than the denominator, then we've got to be careful, because we're not sure be careful, because sometimes the limit is going to be positive infinity, sometimes it's going to be negative infinity. And you've got to think about the sign of the numerator and denominator in order to make sure you make the right choice. All right, so this is all you need to know about the end behavior of rational functions. So it was 5 videos there. So this is enough information for you to do the IXL G3 and really any of the other IXLs in the H series that are talking about this, but G3 is the one I'm assigning you. So you're going to see a really large range of problems, starting from really simple ones and growing to more complicated ones, dealing with limits at infinity and at negative infinity. But if you check back on this video and maybe make yourself, maybe you want to take a sheet of paper and list some rules here, or list a little flow chart that you want to think about. And that will, this is a trail that you will succeed at. Let me know if you have any trouble. So remember, you can always catch me in Zoom sessions if you are not a student. Well, even if you are a student that I see 2 days a week, you can still come to my Zoom sessions on the days that you're not here, or catch me in a learning lab if you are here. And in either case, we will get through this and we will move on to using these limits to solve more complicated problems and to start getting into this notion of derivatives and attacking the slope problem that we talked about at the beginning of the year.